Hello everyone. So we are going to start with a new lecture session. Now the topic for this lecture is Rosenbaum's perceptron model. Now basically what is Rosenbaum's perceptron model? Firstly, we need to understand what is it. It is nothing new, but it is a type of neural network architecture which was used in very early stages. So that is why I have given it a heading which you can just understand it, that is early neural network architecture. So it was architecture which was designed by a scientist called Rosenblatts, and he used this particular architecture which was based on human eye, that is based on retina of the eye. So that is why this particular name perceptron is given. So I've written perceptron is a, what is it? It is a combination. It is a computational model of the retina of eye, hence named perceptron. Now, this particular architecture comprises of three main units. These particular main units are called as, the one you can see out here, this is termed by S, which is called as sensory unit. Second, this is known as A unit, or it is full form is association unit. And the third unit is R, that is response unit. Now, as we have done in neural network architecture, we already know the basic concepts of it. That is, certain input is given and those particular inputs are attached to the new unit with the help of certain weights. So here also these particular two units are attached with the help of weights. That means there's a link between the two units which is defined as weights. So the weights which are between, or which are linking the sensory unit to the association unit, these two are called as weights which are fixed weights, and these particular are randomly connected. There is no defined pattern of connection. So these are fixed weights. That means whenever the iteration is done in neural network, the training is done, these particular weights will not change at all. They will remain fixed. Now, when we talk about the two units, that is association unit and the response unit, association unit and the response unit, these two units are also connected with the help of weights, but the only difference is these particular weights are adjustable weights. These are not fixed. Now, this particular S unit is defined with the help of photodetectors. That means these unit consist of photodetectors which are taking as certain input, and these particular are 400 photodetectors which receives input signal. So these particular sensory unit will get the input which is a electric signal. So electric signal means either we will get a 0 or a 1. But how we can define that we will get a 0 or 1 is if the input signal exceeds the threshold value. If you remember, in the earlier neural network architecture, we have done a threshold value. That means we compare it. So this particular input signal, if it exceeds with a threshold value, the photodetector output will be 1. And if it is less than the threshold value, then the output will be 0. So these particular weights are randomly attached out here. Now, if we talk about association unit, what is association unit? This particular unit is comprising of predicates. I've just defined out here. That is, this particular unit is comprising of predicates. The output of S unit for specific feature of the image. That means the output which we get is specific to the image, or we can say it will be specific to the problem we are solving. Now, what is this R unit? R unit is the unit in which we have pattern recognizers, in which the perceptrons are defined. Now we move to the further slide. This is what I have defined you regarding the S unit, A unit and R unit. Now in this output, this particular R unit is considered as the output. it will always receive a binary form of predicate. There are weights, I already told you, the weights which are connecting the S unit to A unit are fixed weight, while the weights which are connecting the association unit to R unit are the adjustable weights. Now, the output is depending on what? We always calculate the net output, right? What was the net output? In the earlier sections also we have done, the Y was the final output, and how we calculate the Y? It was when the net output is passing through the weighted sum is passing through a function. This particular net j is what? This is the weighted sum. That means all the inputs from I to n, xi is the input and wij is the weight which is linked to it. So the summation, this particular is the net j. So if at all the yi is equal to, will be equal to 1 if the net j is greater than 0. That means whenever the net weighted sum is greater than 0, we'll get the output as 1. Otherwise, we'll get the output as 0. And here, what are these particular abbreviations? We are using notations. Xi is the input, wij is the weight, and yi is the output. So this is how the Rosenblatts perceptron model calculation is done. Our output is defined. Now we define a training algorithm for training the perceptron model. This particular training is done in a supervised way. Supervised learning, if you all remember, we have done this particular part in the lecture where we discussed the types of learning: supervised learning, unsupervised learning, recurrent, etc., etc. Sorry, reinforcement, etc., etc. Now here, what we have to do in supervised learning, just review back. What we were doing, we were trying to adjust the weights. Why we need to adjust the weight? We need to adjust the weight to minimize the error. Whenever we compute the output, if the output matches the target output, then we do not have to adjust the weight. If the target output does not match the actual output, then we have to adjust the weight. So the algorithm which we are working on for this particular perceptron is, see, there will be three conditions. First of all, we need to understand that we are going to compute the actual output with the help of a network, neural network. We will have a certain target output. Target output will be compared with the help of actual output. The comparison or the difference will be giving you the error. If the error is 0 or approximately equal to 0, then we do not have the need to adjust the weight. So this is the first condition, that is, if the output is correct. That means how we can define the output as correct? When the error is approximately equal to 0. And when it is approximately equal to 0, whenever the actual output is approximately equal to the expected output or the target output, then we do not need to adjust the weight. So how we will define this equation? That means this is wij k plus 1 is the new weight, and wij k is the new weight, old weight. So the new weight is going to be the same as the old weight. There will be no adjustment. So that is why this is equal. Now, second condition, if the output is 1, if the actual output is 1, but it should have been 0, then the weights are decreased on the active input links. That means if I compute the output and I get the result as 1, but it was expected to be 0, that means I have defined more weights. I have to decrease the weight which was used earlier. So what I'm going to do, I'm going to decrease the weights on the active input link. So this is the new weight, wij k plus 1. How I am going to calculate the new weight? It will be equal to the old weight, that is wij raised to the power k, minus alpha dot x multiplication. This is, what is alpha? Alpha is the learning rate parameter. Now this is constant. And what is x? X is the input. that is the active input link. So this what we are going to use the equation in the condition whenever the output is 1 but it should have been 0. Now the third condition, just the vice versa of this earlier condition, second condition, if the output is 0 but it should have been 1, that means we are getting less output and it should have been expected output is 1. Then the weights are to be increased on the active input link. So we will work on the same way, but what we are going to do, we are going to just increase the weight on the input link, active input link. So the new weight will be equal to, that is Wij k plus 1 will be equal to the old weight, that is Wij raised to power k, plus alpha, that is the learning rate parameter, multiplied by the xi, that is the active input link. So these are the three conditions which we are going to work on, and we are going to adjust the weight again and again till we reach the first condition, that is the output is correct, when we do not have to adjust the weight, and we will stop the iteration then and there only. So these are what we have already discussed. Wij raised to power k plus 1 is new adjusted weight. Wij k is the old weight. Xi is the input link, and alpha is the learning rate parameter. Thank you very much.